Example 1. Evaluate the limit xy tends to 0 0 x square minus y square divided by x square plus y square if exist. So now if we take the repeated limit here, say step first, a repeated limits, then limit x tends to 0, limit y tends to 0, x square minus y square divided by x square plus y square is equal to, now if we take limit y tends to 0, then it is equal to limit x tends to 0 x square divided by x square, which is equal to limit x tends to 0. If we cancel this two term, we get here it is equal to 1, so limit is 1, and limit y tends to 0, the second repeated limit is x tends to 0 x square minus y square divided by x square plus y square is equal to limit x tends to y tends to 0. If we take x tends to 0, it is minus y square divided by y square, so it is equal to limit y tends to 0 minus 1 is equal to minus 1. So now both repeated limit exist but not equal, and therefore since 1 is not equal to minus 1, therefore limit does not exist. Does not exist. Second example, example number 2. Find domain and range of function f of xy is equal to under root of y minus x square, and also sketch the domain. So now here we want to determine the domain. So here domain is equal to collection of all xy belongs to R square such that y minus x square is greater than or equal to 0. In other words, it is collection of all xy in R square such that y is greater than or equal to x square. Now for square root function, the range is equal to 0 to infinity. Okay, or if you draw the region, so we know that y equal to x square is what? This is the y equal to x square, and y axis represent a range. So here range is equal to what? You can see the range is equal to, I am going to highlight here. Okay, so this is the range here. This represent the range. So it is what? 0 to infinity. Now we want to sketch the domain. Here what is given? Y is, the domain is what? Y greater than or equal to x square. So if we select this point, say here, say this is the point, say 0 2, and if you put here 2 greater than or equal to 0 is true, so our region is, this is the region which is this is the domain of the given function y equal to x square. So we can highlight this region. Okay, this is what the region y greater than or equal to x square. So hope you understood. Next example number 2. Okay, change the order of integration. On to number 3. Change the order of integration, say -1 to 1 integration 0 to under root of 1 minus x square f of xy dy, say it is dy dx. So now given it is y equal to square root of 1 minus x square implies this is equal to squaring on both sides, we get x square plus y square equal to 1. So now if we draw this region, then it is the equation of circle having center at origin and radius is equal to -1. So now given x is from given x is from -1 to +1 and strip enters at x is equal y equal to 0 and leaves at y equal to 1 minus x square. So this is the region which is okay. This is the region of integration. Now we want to change the order of integration. So if you observe, if you take this strip, then it enters at, now here x is negative, so it enters at under root of 1 minus y square and leaves at x is equal to under root of 1 minus y square. Okay, 1 minus y square. So the limit is, this is equal to the limit of and limit of y is from 0 to 1 and limit of x is minus under root of 1 minus y square to under root of 1 minus y square f of xy dx dy. This is the semicircle. Okay, our original strip is what? Our original strip is, this is the original strip. It enters at y equal to 0 and it leaves at y equal to under root of 1 minus x square. So this is the answer here. This is the answer. Okay, now example number 4. Example number 4. We want to determine at what point the function 1 upon x square plus y square plus z square is continuous. Okay, we want to determine as continuous. Okay, at what point this function of this is the f of x y z, we want to determine at what point this function is continuous. Now this function is discontinuous if we get x square plus y square plus z square is equal to 0, and this is only possible if x is equal to 0, y equal to 0 and z is equal to 0, and therefore the f of x y z is continuous on r cube minus only single point 0 0 0. If you remove this point, then this function is continuous continuous on the given region. Okay, so just remove the point 0 0 0 from r cube, you will get the continuous point. Now the next point, find the extreme values. So say 5, find the extreme points of the function f of xy equal to x square plus y square minus twice x plus 4y plus 6. So for the extreme points, that is for critical point, we want to determine the critical points here, extreme values. So f of x is equal to 0 implies twice x minus 2 equal to 0, and f of y equal to 0 implies twice y plus 4 equal to 0. So this implies x is equal to 1 and y is equal to what? -2, and therefore critical point is equal to 1 minus 2. So this is the answer. Next example, example number 6. Okay, find the critical points of the equation. Say sin x f of xy equal to sin x plus sin y plus sin of x plus y. Determine the critical points. So here f of x is equal to 0 implies cos x plus cos of x plus y equal to 0, and f of y equal to 0 implies sin cos y plus cos of x plus y equal to 0. So if you subtract these two equation, then we get this will get cancelled here, and we get cos x minus cos y equal to 0. So this implies cos x is equal to cos y, and this implies we get condition x is equal to y. Now if you substitute this condition any one of these equation, we get now since cos x plus cos of x plus y equal to 0, in this equation if we put x is equal to y, then we get cos x plus cos twice x equal to 0. Now if you simplify this, we get cos twice x is equal to minus cos x, but we know that the minus cos x is nothing but the cos twice x is equal to cos of pi minus x. So this is equal to minus cos x. So this implies if we equate on both sides, we get cos x is equal to pi minus x. Okay, so this implies thrice x is equal to pi, and this implies x is equal to pi by 3. Now since x is equal to y, you can see here x is equal to what? Y. So y is also what? Y is also pi by 3, and therefore critical point is equal to pi by 3, pi by 3. So this is what? Critical point. Now the next example, find the Jacobian of given, say example number 6 7. Find critical Jacobian of, find Jacobian uv and given x is equal u is equal to x plus y and v is equal to x minus y. So if you add here u plus v, then we get it is equal to twice x, and this implies x is equal to u plus v divided by 2. And if we subtract here, say v minus u, then it is equal to twice y, and it is equal to y is equal to v minus u divided by 2. So u minus v, sorry, not v minus u, this is equal to, this is wrong I think. If we take u minus v, then it is equal to x plus y minus x plus y, so x will get cancelled here, and y is equal to u minus v divided by 2. So this is y and this is x. So Jacobian is equal to Jacobian of uv is equal to dabba x divided by dabba u, dabba x divided by dabba v, dabba y divided by dabba u, dabba y divided by dabba v. So this is equal to dabba x by dabba u is equal to 1 by 2, 1 by 2, 1 by 2, 1 by 2, and minus 1 by 2. So this is equal to minus 1 by 4, minus 1 by 4. So this is equal to minus 1 by 2. So this is the Jacobian. Now the next example, find the equation for level curve. Find the equation for level curve passing through the point. Say point is given, point is 2 root 2 to root 2, and f of xy is equal to say 16 minus x square minus y square. So we want to determine the level equation of level curve that passing through this point. So just put here x is equal to 2 root 2 and y is equal to root 2. We get 16 minus 2 root 2 square, so 2 root 2 square minus root 2 square. So this is equal to 16 minus 8 minus 2. So this is equal to what? C. So this is our value of say 6 is equal to, this is the value of c, and we know that the equation of level curve is f of xy is equal to what, c. So this implies 16 minus x square minus y square is equal to 6. So we get here x square plus y square is equal to 16 minus 6 is what, 10. So this is what the equation of level curve that passing through the given point. So we want to determine next example number, find area which is bounded by y equal to x and y equal to x square. We know that if we draw this graph, then we get this is the equation of y equal to x and this is the equation of y equal to x square. So if we consider a strip, it enters at y equal to x square and leaves at y equal to x, and want to put such a strip from 0 to 1. So if we evaluate this integration 0 to 1 and x square to x, f of x f of x y not dy dx, you will get the value of area. Thank you.